students, welcome back to our channel Diksha Karnataka. So now your midterm exams are approaching, right? And many of you will be preparing very hard for your examinations. So to help you with this preparation and by seeing your request, many of you have asked for midterm revision. So today I have come up with the Inorganic Chemistry revision, okay, for your midterm examination. We'll be discussing the topics D and F block elements and coordination compounds, okay. So I'll be telling you the most expected questions. So I have picked up these questions from the model test question papers that is released by the PUC board for 2024 and 2025, and I have also analyzed last 10 to 15 years of question papers, and I have seen many questions are repeated, okay. So I have picked up all those important questions and I have come up with this video. So if you are preparing for your midterm examination, if you are facing any difficulty, please watch this complete video, solve all the questions that I have discussed here, and this will definitely help you to score good marks in your midterm examination, okay. So now, as I tell you in my every class, please sit with a notebook and a pen and note down the questions, try to write down the answers, and then see the solutions and then match whether you are written correctly or not, okay. And you can also check the level of your preparation in this way, okay. So now, without any further delay, let's get started, okay. Fine. So now if you see, in organic chemistry we have two chapters, that is the D and F block elements and the coordination chemistry, right. So we'll start with the first chapter, that is D and F block elements. So the total weightage of this chapter is 10 marks, okay. So you'll be getting questions like 10 marks questions will be asked from this particular chapter. Now what are the type of questions asked here? Now if you see, there will be two VSA, that is 1 marker question. This can be MCQ or fill in the blanks, but most probably it will be MCQ. And what are the type? Like these two questions, one will be of remember type, one will be of your understand type, right? That means one will be directly from any theoretical and the understand will be little tricky, where you need to understand the concept and you need to apply it, okay. Next, coming to short answer questions, 2 marks, you will have one question from here and that will be of remember type. Now if you see short answer 3 marker question, okay, so you will get 2 3 marker question, and one will be of your remember type, another will be of your H type, means HOTS question, high order thinking skills, okay. So that question will be little tricky, or you can say little not very direct question, okay. So clear now the question pattern. So total how many questions will be asked? 2 to 4 plus 1, 5 questions will be there, 2 MCQs, 1 2 marker and 2 3 markers, okay. So now if you have understood the pattern, you have understood the mark distribution, let's go and practice questions now, okay. Fine. So coming to the first question. So these MCQs I have taken from your NCERT exemplar, okay. So that is also very important. Their questions are little of higher level. So if you are able to solve this, not all, but yeah, some of the questions are from your exemplar also, okay. So let us try now. Electronic configuration of a transition element X in +3 oxidation state is Ar3D5. What is the atomic number? Now, before starting D and F block, before solving any questions of D and F block or coordination chemistry, one thing that you must do is the remembering of electronic configuration of scandium to zinc. If you have solved, if you have understood, if you have remembered the electronic configuration, then you will be able to solve many questions like color based questions, magnetic based questions, this type of MCQs, very easily you can solve it, okay. So please remember, first study the electronic configuration, then come and start solving questions, okay. Fine. Now if you see what is the atomic number, Ar3D5 plus 3, means if you see we will have iron, atomic number is what? 26, right? The electronic configuration is Ar3D6 4s2. Now if you have Fe plus 3, then we'll get 2 electrons will be lost from here, 1 electron will be lost from here, so I'll get Ar3D5, right? So what is this element? Iron. The atomic number is 26. Correct answer will be option number B, okay. Now going towards the next question. The electronic configuration of copper 2 is 3d9, whereas that of copper 1 is 3d10. Which of the following is correct? Statement based question again now here. Now see, copper 2, if you have Cu plus has D10 configuration, right? It is a very stable configuration, but we know that it undergoes disproportionation reactions to give you this one, right? Now this is very stable due to its high hydration enthalpy. So Cu2 plus is more stable even though it has D9 configuration, right? So Cu2 plus is more stable. Option number A. Okay, what is the reason for the stability of Cu2 plus? High hydration enthalpy. Okay, let us see the next question now. Metallic radii of some transition elements are given below. Which of these elements will have the highest density? Okay, so if you have remembered the density graph, so iron, nickel, cobalt, copper, right? So the graph increases like this after copper, and then to zinc the density decreases. So copper has the maximum density. Correct answer is option number D here. Next, generally transition elements form colored salts due to the presence of unpaired electrons. Now which of the following compounds will be colored in the solid state? So for colored, what is required? Unpaired electrons. Okay, so now if you see here, Ag oxidation state is +1, right? So in this there is no unpaired electron. And if you see here, copper +2, this is copper +2, so 1 unpaired electron is there. Zinc, no unpaired electron. This is copper +1, no unpaired electron. So that is why option number B will be correct answer, because here copper is in +2 oxidation state, and copper in +2 oxidation state has D9 configuration. D9 configuration, if you see, we have 3, 4, 5, 6, 7, 8 and 9. One unpaired electron is there, right? So because of this one unpaired electron, it can undergo DD transition and then we can see color. Okay, so option B is the correct answer. Next, on addition of a small amount of KMnO4 to concentrated H2SO4, a green oily compound is obtained which is highly explosive in nature. So this green oily compound which is highly explosive in nature is Mn2O7. Okay, I'll show you the reaction here. So you can see KMnO4 with concentrated H2SO4, okay, will give you Mn2O7 plus KHSO4 plus water, and this is your green color compound which is highly explosive. Okay, next one, the magnetic nature of elements depends on the presence of unpaired electrons. Identify the configuration of the transition element which shows the highest magnetic moment. So magnetic moment, remember, is directly proportional to the number of unpaired electrons. Okay, so if you have 3d7, right, so how many unpaired electrons will be there? So we can draw like this, 1, 2, 3, 4, 5, 6 and 7. So there are 3 unpaired electrons here, 5 unpaired electrons here, then 3d8. So 5, 6, 7, 8. We have 2 unpaired electrons here, and here also we have 2 unpaired electrons. So maximum is here. Maximum magnetic moment will be option number B. Okay. Now next question. Which of the following oxidation state is common for lanthanides? So lanthanides has +3 oxidation state. Next, which of the following reactions are disproportionation reaction? So disproportionation reaction means what? The same element undergoing oxidation as well as reduction, right? So if you see here, copper plus, okay, +1 to +2 is oxidation, +1 to 0 is reduction. So yes, this is a disproportionation reaction. Now if you see here, manganese is in +7 oxidation state, here MnO4 is in +6, and here it is +4. So it is +7 to +6, again +7 to +4, it is a reduction reaction. And here this is not a redox reaction at all. So correct answer is option number A, only one. Okay. Next, when KMnO4 solution is added to oxalic acid solution, the decolorization is slow in the beginning but becomes instantaneous after some time because of. So when KMnO4 is added to oxalic acid, okay, so what happens? It oxidizes oxalic acid, C2O4 2- is oxidized to CO2, and Mn+7 is reduced to Mn plus 2. Right? Now this Mn2 plus acts as a catalyst here, okay, and that is why the reaction fastens after some time. So Mn2 plus acts as an autocatalyst, option number D. Okay. Now next one, there are 14 elements in the actinoid series. Which of the following does not belong to this series? So Tm is not a part of actinoid series, it is a part of lanthanoid series. Okay. Now it is a 13th element in the lanthanide series. Okay, out of 14th element, 13th element is Tm. Now next one, KMnO4 acts as a reducing agent in acidic medium. The number of moles of KMnO4 that will be needed to react with 1 mole of sulfide ions in acidic solution is. This can be an application based question, or you can say an understandable questions, which is little tricky. Okay, so now you know that in acidic medium what happens? MnO4 minus will get converted to Mn plus 2, right? Plus 7 to plus 2 with 5 electrons. And to react with 1 mole of sulfide ions. So what happens? Sulfide ions get converted to sulfur, right? So now here what happens? 2 minus to 0, that is oxidation. So this will happen with the loss of 2 electrons. Right? Now to balance out the equation, what I can do? I can multiply this equation with 5 and this equation with 2, right? Sorry, one second. This equation with 5. The number of electrons lost and gained should be same. So what will I get? 2 MnO4 minus, okay. Then we will get 5 S2 minus. Okay, I'm not balancing any other thing, I'm just balancing manganese and sulfur. Okay, we need to balance oxygen also, but that is not required to solve the question, so we haven't done it. Right, now the question is the number of moles of KMnO4 that will be needed to react with 1 mole of sulfide ions. So if you can see, 5 moles of sulfide ions reacts with 2 moles of KMnO4, right? So to react with 1 mole of sulfide ions, we will require 2 by 5 moles of KMnO4, right? So correct answer is option number A, 2 by 5. Okay, so this is an important question. Many a times this type of question is asked with the chromium, especially with chromium and with manganese, you can expect such questions. Okay, next one. Which of the following oxides is amphoteric? So what's the meaning of amphoteric? Amphoteric oxides means they will have both acid as well as basic nature. Okay, so these you have to remember the examples, V2O5 and CrO3, option number A. Okay, here I'll tell you one thing, if the generally lower oxidation states will behave as an base. Okay, medium oxidation states behave as amphoteric and high oxidation state behave as acids. Okay, next question. Gadolinium belongs to 4F series. Its atomic number is 64. Which of the following is the correct electronic configuration of gadolinium? So gadolinium, why you should remember? Because gadolinium 3 plus is very stable. So this is the configuration of gadolinium. So you should remember this element. Okay. So gadolinium 3 plus will give you 4F7, which is a half filled configuration, so very stable. So that is why this particular element configuration you should remember. 4F7, 5D1 and 6S2. Okay. Next question. Interstitial compounds. We know that transition elements form interstitial compounds are formed when small atoms are trapped inside the crystal lattice of the metals. Which of the following is not the characteristic property of interstitial compounds? So they have high melting point. Yes, that is a property. They increase the they increase the melting point and boiling point of the compounds. Okay, so that is a property of interstitial compound. Very hard, yes, this is also there. Retain the metallic conductivity, yes, they are chemically very reactive. This is wrong. Even though some atoms are trapped inside the voids, but still they have what? They are non-reactive. Okay, they do not change the chemical reactivity of the particular compound. So option number D. Okay, next. Magnetic moment is associated with the spin momentum and orbital angular momentum. The spin only magnetic moment of Cr3+. So chromium atomic number is 24. Electronic configuration 3d54s1. Cr3 plus will be 3d3. Right? So if you remember 3 electronic configuration, so what is the magnetic moment formula? Root over of n into n plus 2. So that is 3 into 3 plus 2. So that is root over of, sorry, 1 second. The whole root over is there, n into n plus 2, root over of 3 into 3 plus 2, so that will be 3.8. And I have told you a trick also to remember here. If it is 1, a number of unpaired electron is 1, magnetic moment will be 1.7. 2 it is 2.8, and for 3 it is 3.8, for 4 it is 4.9, and for 5 it is 5.9. Okay, so like this you can remember. So without calculation also you can easily find out the answer, that is option number B. Okay, next, KMnO4 acts as an oxidizing agent in alkaline medium. When alkaline KMnO4 is treated with Ki, iodide ion is oxidized to. So this you should remember, it is oxidized to IO3 minus. Okay, so I minus to I2 in acidic medium. Okay, and I minus to IO3 minus in alkaline medium. Okay, next, which of the following statements is not correct? Okay, copper liberates hydrogen from the acids. If you remember, the reduction potential of copper is a positive value, right? That is 0.34. So that is why copper cannot liberate hydrogen from the acid. So this statement is not correct. Correct answer will be option number A here. Next, when acidified K2Cr2O7 solution is added to SN2 plus, then SN2 plus changes to. We know K2Cr2O7 is what? It is a strong oxidizing agent, right? So SN2 plus will get oxidized to SN4 plus, option number C here. Okay. Next, highest oxidation state of manganese in fluoride is +4, but highest oxidation of oxides is +7. Now because of what? Fluorine is more electronegative than oxygen? No, that doesn't play any role here. Fluorine does not possess d orbital, that even oxygen doesn't possess. Fluorine stabilizes the lower oxidation state? No, fluorine stabilizes the higher oxidation state. In covalent compounds, fluorine can form single bond only, while oxygen can form double bond. Okay, that is the reason. So what happens here? See, higher oxidation states are generally stable by fluorine and oxygen. But if a question is asked, out of fluorine and oxygen, which is a better, which can be stabilized better, then answer has to be fluorine. Okay, this is because fluorine can form which can stabilize better, that is oxygen, because oxygen can form multiple bonds. Okay, next, although zirconium belongs to 4D transition series and hafnium belongs to 5D transition series, they have similar physical and chemical properties because. So this is an example of lanthanide contraction. You know, zirconium and hafnium have similar radii, that is why they have similar properties, right? They both have same atomic radius, and what is the reason for this? Lanthanide contraction. Next, why is HCl not used to make medium acidic in oxidation reactions of KMnO4 in acidic medium? So, like for example, you want to do some reaction in the acidic medium. The oxidizing agent is suppose KMnO4 in that reaction, then you cannot add HCl to make the reaction acidic in nature. Okay, because why? KMnO4 being a very strong oxidizing agent oxidizes Cl minus to Cl2. Okay, so oxidizes HCl into Cl2, which is also an oxidizing agent. That is your option number B is correct. Okay, so now students, see, in this chapter there are also like 1 2-marker question is there. I have not taken the 2-marker questions separately. In the 3-marker questions I have made it like 2 plus 1. Okay, so that will what you will do, you can also practice 2-marker. The first part will be like 2-marker question, and the second part, if it is asked together, it will be a 3-marker question. Okay, so I have taken such questions where together you can practice 2 markers and 3 markers. Okay, so now let us see first question. Study of actinoids element is more difficult, give any 3 reasons. This can be give any 2 reasons. Okay, so I will be telling you 3 reasons, you can write any 2 if it is asked in a 2-marker question, or you can write all the 3 if it is asked in the 3-marker question. Okay, So what is the reason for this? You can see the answers here. They are radioactive in nature. Okay, actinoids are radioactive in nature. Their half-life values are short, means in a very small period of time the molecules disintegrate into smaller particles. And next one, prepared in nanogram quantities. Okay, they are present in very small amount. They are in nanogram quantities they are found, so it is very difficult to study actinoids. For 2 markers, any 2 points you can write. First point, they are radioactive. Second point, they have very short half-life. And the third point, they are found in nanograms. Okay, fine. Let us see the next question. So this question, again you can say it's a 3 marker and can be type a HOTS question. Okay, a student of 2nd PU, okay, a student of your age, you can imagine some of your classmates here, performs 2 trails of reactions. So these questions have been taken from the blue model question paper that is released by PUC. Okay, I think this is the question of the first model paper. Okay, performs 2 trails of reactions between Ki and KMnO4. A student or one of your friend does a reaction between Ki and KMnO4. Okay, in the first trail, in the first experiment, students add small amount of acid to the reaction mixture, and in the second trail student forgot to add acid to the reaction mixture. Okay, so in the first medium, in the first reaction the student did not add any acid. In the second reaction the student added in the first reaction the student added some amount of acid, and in the second reaction student forgot to add any acid. So what is given to us? In the first case acid was there, right? In the second case acid was not added. Okay, what is the reaction happening? KMnO4 plus Ki plus some acid, right? And here it is KMnO4 plus Ki plus there is no other compound here. Okay, so now then the student observed that the different color was obtained in the first and the second trail. Give reason for above observation. Write the possible chemical reactions to both. Okay, so if you write the give reason, if you give the correct reason, that will carry 1 mark. Okay, and you write 2 chemical reactions, so that will give you 2 marks. So total it will be a 3 marker question. So now we will see the answer here. So you know KMnO4 behaves in a different way in the acidic medium and in the non-acidic medium, right? So manganese gets converted from +7 to +2 in acidic medium and +7 to +4 in neutral, +7 to +4 in neutral medium. Okay, so these are the reactions you can see here. In the presence of acidic medium, the oxidation number of Mn changes from +7 to +2, and in basic medium from +7 to +4. Okay, so this carries 1 mark. The first part, give reason. Now you have to write the chemical reactions for both of them. So the first one here will be MnO4 minus, this is from Ki, MnO4 minus gets converted to MnO2, okay, and then you have IO3 minus, right? So this is when no acid is present, so you get iodate ion. Now if MnO4 minus in acidic medium, I minus gets converted to I2, okay. So because here the product is IO3 minus and here the product is I2, the 2 different colors will be observed, okay. So this question is again important. You should know the complete reaction and you should know what is the reason for that. So now if you can see, if MnO4 minus in no acidic medium will get converted to Mn plus 4, right. So if you check the oxidation state here, this is +7, right, and this is +4. And I minus in no acid, that is in alkaline medium, gets converted to IO3 minus, that is iodate. In presence of acid, this one will get converted to I2, okay. Now let us see the next question, okay. When a chromite ore A is fused with sodium carbonate in free excess of air and the product is, so first what I have done, we have taken chromite ore A, okay, it is fused with sodium carbonate, okay, in excess of air, so I can write just O2, and the product is dissolved in water. A yellow solution of compound B is obtained. So after this we get B, which is yellow, okay. Next, after the treatment of this yellow solution with sulfuric acid, okay, compound C can be crystallized from the solution. So we get compound C here. Next, when compound C is treated with KCl, okay, KCl, orange crystals of compound D is formed. So this is orange crystals. Okay, so you need to write all the reactions. Actually, it is not reactions. You need to just tell me what is the A to D. Okay, what are the components present in A to D. Okay, so you can see here, if you remember the preparation of dichromate, in that part it is there, right? So first of all, sodium chromate, A is so iron chromate which gets converted to sodium chromate. Sodium chromate gets converted to sodium dichromate, and then sodium dichromate gets converted to potassium dichromate. Okay, so this is very important. This you have remembered in the preparation of K2Cr2O7. Okay, next question. Fluorine has the ability to stabilize most of the transition elements in the higher oxidation state. That we have just discussed now. Fluorine and oxygen both have the ability to stabilize the elements in their higher oxidation state. Now, what is the reason for that? For oxygen, we have discussed that it has the ability to form multiple bonds. But why fluorine? What is the speciality in fluorine? So, there are two reasons here. Fluorine's ability, fluorine's ability to stabilize the transition metals in the higher oxidation state is due to its high lattice energy and high bond enthalpy. Okay, high lattice energy and high bond enthalpy. Now, for giving an example, you have to write, like, if high lattice energy we take, then here the example is COF3. Cobalt is in +3 oxidation state. It is stabilized by fluorine due to the high lattice energy of COF3. Now, if you talk about high bond enthalpy, and here the example is VF5 or CrF6. So here also you can see vanadium is in +5 oxidation state, Cr is in +6 oxidation state. These both are high oxidation states and they are stabilized by fluorine. And what is the reason for that? High bond enthalpy. Okay, and now if we talk about lattice energy, the example is COF3. So you need not write the examples much in detail. You can just write any one example. Okay, so two reasons are clear. First is high lattice energy. Second reason is high bond enthalpy. After that, you can write any one example. You need not write the example separately. Okay, clear? Next question. What is lanthanide contraction? Name two elements of actinoids which exhibit the +7 oxidation state in their compound. Okay, so very easy. Lanthanide contraction, all of you will be knowing. The steady decrease in the size of in the atomic radius of the elements along the lanthanide series due to the poor shielding effect of 4f orbitals, right? So lanthanide contraction is the gradual, or you can write steady, decrease in the size of the atoms and ions of the lanthanide series. And why this happens? Due to the poor shielding effect of 4f orbitals. Okay, and what are the examples of the elements of +7 oxidation state? Neptunium and plutonium. Okay, Np and Pu. Okay, the transition elements have high enthalpy of atomization. Give two reasons. Now, among 3D and 4D series of transition elements, which series has high enthalpy of atomization? Now, see the answer here. You can write that in the case of transition elements, there are unpaired electrons. Okay, first reason. Now, second part you can write, these unpaired electrons are involved in metallic bonding. Okay. Now, because of this metallic bonding, what happens? The interatomic forces increases and the enthalpy or the transition elements have high enthalpy of atomization. Clear? Now, two reasons given. Next, among 3D and 4D, which will have the higher enthalpy of atomization? 4D will have higher enthalpy of atomization than 3D. Now, reason is not asked here, but we can explain that is because of the size. Okay, as the size increases, the outermost electrons are less attracted towards the nuclear force. So, the outermost electrons are more free and they can participate in the metallic bonding better. Okay, so that's what is the answer here. You can see next question. Actinoids exhibit a large number of oxidation states. What is the reason for that? So, if you have seen in actinoids, we have what? 5F, 6D, and 7s. So these three orbitals have very comparable energy, and that is why all the electrons from all the three orbitals participate in the bonding formation, and we say that the number of oxidation states shown by actinoids are higher. Next, zirconium and hafnium have similar radii. This is very common example, very important question due to lanthanide contraction. Between scandium 3 plus and Cu 2 plus, which is colorless? So if you remember, for color what we need? Color, what is needed? Unpaired electrons, right? Now if you see, scandium electronic configuration is 3d1 and 4s2. So scandium 3 plus will have what? Argon, and this all will be not there, right? So this will be a total noble gas configuration, okay? So that is why scandium 3 plus will be colorless. So you can see the answer. Sorry, one second. Okay, so you can see the answer here. Comparable energies between 5f, 6d and 7s. Then lanthanide contraction is the reason, and which is colorless. Scandium 3 plus is colorless. Okay. Next, transition elements have catalytic activity. Give two reasons. What is mixed metal? So here, if only this question is asked, that is a 2-marker question. If like this some combined question is asked, that is a 3-marker question. Now catalytic activity is due to the availability of d orbitals, variable oxidation states, right? And what is mixed metal? Mixed metal is an alloy, right, where you can transition elements are there 95% and some other elements are mixed, and this is like used in the to make different parts on the aircraft, and so many other uses are there. Okay, so you can see why transition elements have catalytic activity due to variable oxidation states and their ability to form complexes. Okay, next, mixed metal is an alloy, okay, which consists of lanthanoid metal up to 95%, iron 5%, and traces of sulfur, carbon, calcium and aluminium. Okay, so this is the definition of mixed metal. This is important, please remember this definition. Okay, and why it forms catalytic activity? Because of variable oxidation states and its ability to form complexes. Okay, because it has the ability to form complex, it can bind with the substrate, can form a complex with the substrate and can do the catalytic activity. Okay, next, 3 consequences of lanthanide contraction. Very, very important question, a most repeated question. Okay, very, very important. So you know, as we go along the period, what happens? The size decreases, right? That is called as lanthanide contraction, and this happens due to the poor shielding effect of 4f orbital, right? Now these elements along the series, what happens? Their size becomes very small. Okay, so now it is they have now similar properties, so it becomes difficult to separate them. First consequence. Second, zirco 3d and your 4d and 5d element size becomes similar. Example, zirconium and hafnium. The third one, as we go along the period, the size decreases, so that is why you can say the nuclear force, the effective nuclear charge increases, so the tendency of the elements to donate electrons decreases, and hence the basicity of hydroxides decreases. Okay, so you can see the reason here. Similar atomic size. So what is the consequence of this similar atomic size? It is similar atomic size of 4d and 5d. Here you can mention example, zirconium and hafnium. Okay, now difficulty in the separating of lanthanides, the decreased basic strength of hydroxides. Okay, as we go along the period, the bond becomes stronger and stronger, OH minus cannot be released, the basic strength decreases. Okay, next, balanced equation for the manufacture of K2Cr2O7. So this one you must remember, very important again. Okay, so first is your iron chromite, right? Iron chromite is converted to sodium chromate, right? Now sodium chromate in acidic medium is converted to sodium dichromate. Sodium dichromate again is then converted to potassium dichromate. So this is your step 1, step 2 and step 3. Please learn these reactions, write it again and again, mug up these reactions. This question is a must question in your boards or in the pre-boards or midterm. This question will definitely be asked. Okay. Next, similarly, we have the preparation method of MnO4 from MnO2. You can see the first step, what happens here. MnO2 gets converted to K2MnO4, that is manganate. Okay, MnO4 2 minus. Then MnO4 2 minus in acidic medium gets converted to permanganate, that is MnO4 minus. Okay, so the first step, conversion of MnO2 to K2MnO4, then conversion of K2MnO4 to KMnO4. Okay, so we have what? First MnO2 in the alkaline medium in presence of oxygen gets converted to K2MnO4, then K2MnO4 in acidic medium gets converted to KMnO4. Okay, fine. Next question, calculate the spin only magnetic moment of Fe3 plus Zn2 plus salts are colorless. Why? Okay, so this is again whenever it is asked to calculate the magnetic moment, okay, what should be the correct way? First you need to write the formula. What is the magnetic moment formula? Root over of n into n plus 2. Okay, then you need to write the value of n. You can show the electronic configuration or not, doesn't matter, directly you can write the value of n. In Fe3 plus, if you see, electronic configuration of Fe is 3d6 4s2 and Fe3 plus will have 3d5 configuration, right? So this one will give you 5 unpaired electron. So mu value will be what? Root over of 5 into 5 plus 2, or I can say root over of 35, and this value will be almost equal to 5.9. Okay, so this carries 1 mark and this carries 1 mark, and here do not forget to write the unit Bohr magneton. Okay, this is also very important. Okay, now Zn2 plus salts are colorless. Why? The simple reason, so this is A and this is B, this is colorless due to the absence of unpaired electron. Okay, so you can write Zn2 plus has D10 configuration, because it has no unpaired electron, it is colorless. Okay, next, same answer we have discussed. Next, calculate the magnetic moment of Cr3 plus, which transition element does not exist variable oxidation state. So similar way, first thing you need to write the step 1 to write the formula, carries 1 mark. Next, write the n value, substitute it, calculate the answer with units, this carries 1 mark. Okay. Next, which element does not exist variable oxidation state? Scandium. Okay, scandium has only the oxidation state of +3, right? Okay. Okay, so now we are done with the question practice for coordination, for D and F block elements, where we have discussed 1 marker question, almost 20 questions, and about how many questions? About 13 3 marker questions. But as I told you, these 2 marker questions can easily be collected from these 3 marker questions. Okay, the part A of all the questions you can think as a 2 marker question, and you can practice these questions. Okay, so now we'll start with coordination compounds. Okay, here also I'll be discussing first the mark distribution, then we'll practice questions. Okay, okay, now seeing the mark distribution here, it's where you can see you have here 2 VSA questions. So 2 1 marker questions will be asked, most probably MCQs, and this will be of 2 types. One will be directly remember based, where you can easily apply, and the other one will be of HOTS type. Okay, little higher order thinking skill question. Now if you see, there will be no 2 marker question. In the 3 marker question you will find 3 3 marker questions. Okay, I forgot to tell you the total weightage. Total weightage will be 11 marks. Okay, so you can expect 10 marks from DNF block and 11 marks from coordination chemistry. Okay, so now if you see 3 marker questions, so there are 3 questions with each carrying 3 marks. One will be remember based, understanding based, and one will be HOTS based. Clear? So 2 MCQs, 1 remember and 1 HOTS. Then you have 3 3 marker questions, 1 remember, 1 understanding, and what? HOTS question. Okay, so 3 3s are here 9 and here 10, 11 marks. Okay, next going to the questions. First we'll do some 1 marker VSA questions. Okay, what type of bond is ligand to metal in case of complex compounds? So this, you know, it's a name, it suggests it's a coordinate bond, right? Coordinate covalent bond, option number C here. Next, in the secondary valence in COCl3 4NH3, if the secondary valence in COCl3 4NH3 is 6, the solution conductivity in silver nitrate corresponds to dash electrolyte. Okay, so here this is again an important question. So now if you see, it is saying that the secondary valency is 6, that means the coordination number is 6. Okay, silver nitrate solution is there, so chlorine must be outside, right? So what I will get here, the compound structure should be like this, CO, and we have 4NH3, okay, and then we have 2 chlorine, okay, and 1 chlorine is outside. So now if you see, this is plus, right, like this is 1 and this is minus 1. So this electrolyte is of type what? You have plus 1 and minus 1, or you can say 1 cation and 1 anion will get, okay, 1 cation and 1 anion. If you dissolve this, not plus 1 minus 1, so if you dissolve this, we will be getting 1 cation and 1 anion in the solution, right? So these type of electrolytes are called as 1,1 electrolyte. Okay. Next question, given that 1 mole of NiCl2.6H2O with excess of AgNO3 precipitates 2 moles of AgCl, what is the secondary valency of nickel? So if you see, 2 moles of AgCl is produced, means 2 chlorine will be outside. So if I write like this, so I will get Ni and I have water, 6 water molecules and 2 chlorine ions, right? So these 2 chlorines will react with AgNO3 to give you 2 moles of AgCl. Now what is the secondary valency? Means coordination number, it has 6. So answer will be again option number D, that is 6. Clear? Very simple question. Next, what is the sum of the oxidation number of cobalt in this compound and in this compound? So let us write down this compound little bit separately. You have CO, then you have water, then you have CnEn2, okay, and then 2 plus, right? And another compound is there where you have CO, Br2, then you have En2, okay. So now if you calculate, and this is another plus is there, okay. Now if you calculate, this is neutral, this is minus 1, this is also neutral. So I will take it as x minus 1 plus 2. So x is equal to plus 3. So in the first compound, cobalt is in plus 3 state. Now if you say second one, it is x minus 2 is equal to plus 1, x is equal to plus 3. In the second compound also it is plus 3. Sum will be plus 6, again option number D, plus 6. Okay. Next question. What is the primary valency of the iron in the coordination entity of the compound? Now primary valency refers to what? Oxidation state of metal, right? So now if you calculate the oxidation, so I can, this one must be like this, see, Fe must be plus 3 here and FeCN6 must be 4 minus here. Now after doing, there is a crisscross, here we will get Fe4 and we will get FeCN6 whole 3, right? Now what is the oxidation state of iron here? So if you see, this is X and then this is minus 6 and this is equal to minus 4. So if I solve like this one, we will get Fe is equal to plus 2. So the primary valency is plus 2, that is option number B here, right? Very simple. Next, which of the following compounds has enantiomers? So enantiomers, if you see, we will get if it has optical isomers, right? So now if you see the first one, FeCN6, here all the ligands are same, right? So if you do an octahedral complex, the mirror image and its reflection will be same, so it will not have enantiomers. Now if you see AlC2O4 whole 4, okay, now ZnOH4 tetrahedral does not have, PdCl4 will again same ligands, it will not have. But if you see this one, AlC2O4 is a bidentate ligand, so it will be like this. I'm just representing like this. This is oxalate, okay. Now if you do its mirror image, Al, it will be this one will be like this, this one will be like this, and this one will be like this. So these are what? Non-superimposable mirror images of each other, and that is nothing but enantiomers. So this will exist enantiomers, option number B. Okay. Next, linkage isomerism. So linkage isomerism means when different atoms bind to the metals, right? Linkage isomerism is seen in compounds having which type of ligands? Ambidentate ligand. Like for example, if you have any metal, okay, and let us consider a ligand Cn. If this is binding like this, or it can also bind like this, right? This is called linkage isomerism, and this type of ligands which can bind through two different atoms at different times, not simultaneously, these are called as your ambidentate ligands. Okay. Ambidentate ligands. Okay. Next question. The compounds dash, these two compounds are given are dash isomers. So if you see here, what is there? Here the ions, what ions I'll get on putting this in water? We will get CO, NH3, whole 5, Cl1, and we'll get SO4 another, right? And for the second one, I'll get CO, NH3, whole 5, SO4 and Cl, right? So if you see on ionization, we are getting different ions. Okay, that is called as ionization isomer. So correct answer here is option number C. Now next question. Which of the following orbitals does not belong to T2G orbitals? So T2G orbital, it happens in the case of octahedral splitting. So when it splits like this, we have T2G and then we have EG here, right? And in T2G we have DXY, DYZ, DZX, and here we have DX square minus Y square and DZ square. So DZ square does not belong to T2G set. Okay. Next, identify the correct order of increasing field strength of ligands. Okay, so Cn minus is the strongest ligand. Yes, so that is there in all the options. Next is NH3, right? So that is there. So this option we can eliminate, this option we can eliminate, and then after that we have SCN minus and then we have NCS minus, option number B. Okay. Now next question. Okay. What will be the electronic configuration of D5, okay, in terms of T2G and EG in an octahedral field where delta O is less than P? Now if delta O is less than P, that means it is a weak field ligand. The splitting will be very less. Okay, so how will be the splitting? Like this. The gap, okay, this gap is less. If it is less, then D5 we want, right? D5 configuration. So 1, 2, 3. Because this energy is very less, what will happen? The electrons, instead of pairing up here, they can easily go to the higher energy level. Okay. So 1, 2, 3, here 4 and here 5. So what will I get? Electronic configuration T2G3, EG2. Okay. So that is option number C. Next, identify the correct naming of K2PdCl4. So first of all, if you see, palladium is a part of anion and the name of the metal in the anion ends with what? ATE. The suffix used is ATE. So if you see here there is EM, here there is EM, eliminate these two options. Here ATE, here ATE, that can be the answer. Now if you see potassium, tetra, chlorine. For chlorine, what should be the name used? Chlorido. Okay, all the negative ligands name ends with chlorido, cyanido, bromido, iodo, hydroxido, right? So that is why potassium, tetra, chlorido, palladate 2. Okay, so we need not check the answers also. By checking the options immediately we can find the correct answer. Okay, now we will move towards the 3-marker question. As I told you, there will be how many 3-marker questions? 3 3-marker questions will be there, right? So that will give you around 9 marks, right? So we need to prepare a lot of 3-marker questions now. Okay, so these questions I have taken from your blueprint for like model test paper, some of those questions. For the complex mercury 1 tetrathiocyanato S cobaltate 3, the following questions you need to answer. First, let us write this complex. Mercury is in plus Hg. Then you have tetrathiacineto cobaltate 3. So cobalt tetrathiacineto means SCN4. Okay. Then what else is given? Okay, this is the compound, right? So are we getting cobalt is in plus 3? Yeah, so if this is plus 3, this is minus 4, this will be minus 1, this will be plus 1. Okay, so this is the name of the compound. This is the compound that we have written. So I'll write this one little bit, one second. So we have the compound like this, HgCO SCN4. Okay. Now if you see, cobalt Hg is in plus 1 state, it is already given here, right? And cobalt is in plus 3 state, that is also given. So if I see plus 3 and here SCN is minus 1 ligand, the charge is negative 1 and there is 4 like this. So we'll get plus 3 minus 4, that is minus 1. So this is minus 1. So now if there will be a crisscross, we will get the compound like this, HgCO SCN4 whole. Right? This is the compound given. What is the coordination number of cobalt? So SCN is a monodentate ligand, so there are 4 SCN, so coordination number will definitely be 4. Identify the ligand present in this complex. Thiocineto, okay, thiocyaneto S means S is connected here, okay. If it is written thiocyaneto N, then it is NCS, okay. Next you have, does ionization isomer of the following compound exist? Now isomerization will happen when different ions are produced on on ionizing it, okay, on dissolving in water. But here we'll get only Hg plus and this ion on dissolving. There is no chance of getting different ions, so that is why no ionization isomers exhibit here, okay. So yeah, this is the compound, coordination number 4, SCN minus, okay, SCN minus ligand and no ionization isomer. Okay, next question. Define crystal field splitting. Sketch the energy level diagram of crystal field orbital splitting in the tetrahedral complex. Now what is crystal field splitting? So when ligand approaches, okay, the degenerate d orbitals get splitted into different energy level. That is called as crystal field splitting energy. So how will you define it? Crystal field splitting refers to the you need not write this much complex name, you can just write crystal field splitting happens or occurs when the degenerate d orbitals of a transition metal ion experience a change in the energy level when surrounded by ligands in a coordination complex, okay. I'll tell you in a much simpler form how to write it. You can write when the degenerate d orbital, okay, this word is important, degenerate d orbitals of transition metal, okay, when the there is an undergo splitting due to the presence of ligands, okay, is called as crystal field splitting energy, okay. Now for tetrahedral, if you can sketch the diagram. Here in the lower level it will be E, in the upper level it will be T2, right. And what is the orbitals here? dx square minus y square, dx square minus y square and dz square, and here it is dxy, dyz and dzx, okay. So you need to write down these levelings properly, okay. So first is when there is d orbitals. Now in the spherical crystal field the energy increases, in tetrahedral crystal field it splits in this way, okay. So please remember, you need to draw this particular diagram, all the leveling should be there, this one energy, this one also, do not forget, okay. Very easy question. If you draw this diagram you will get easily 3 marks. Next, what is the significance of synergic effect in metal carbonyls? How many bridged and non-bridged CO ligands are present in octacarbonyl dicobalt complex compound? Okay, So strengthen, what is the significance? Because of synergic effect. What is synergic effect? If you remember, see, metal is there, okay, and carbonyl group is there. So we have studied that in case of metal and carbonyl, first there is a sigma bond is formed, coordinate bond is formed, which is a sigma bond. What is this? And after that, metal also, what happens? You have metal also donates electron from its filled d orbital, okay, from its filled d orbital to the empty pi star orbital of CO. So that is what happening. This is called as back bonding, okay. So because of this back bonding, what happens? This MC bond is strengthened, okay. The bond between the metal and the carbonyl is strengthened. So that is the significance, okay. Now how many bridged and non-bridged CO ligands are there in the, so if you have to remember the structure for this one, so I will show you the structure. So okay, so this is the structure of this compound, which is given octa carbonyl. So 8 carbonyl groups are there, 1 2 3 4 5 6 7 8, octa carbonyl dicobalt. So there are 2 cobalt groups here, right? Octa carbonyl, okay, then dicobalt, okay, complex compound. So how many bridge are there? So total bridge is 2 and non-bridge, or you can say non-bridge will be 6, right? So this is a bridge carbonyl, this is a bridge carbonyl, and you have 1 2 3 4 5 6 non-bridge carbonyl compounds, okay. Next, write the IUPAC name of COCl2En2 whole plus, draw the geometrical isomers for this complex, okay. First let us write the IUPAC name, okay. So you can see this is a cationic complex, and in cationic complex first we need to write the name of the ligands, and the ligands name should follow alphabetical order, right. So now if you see, this one will be chlorido, and here for En we use the word bis. Bis ethane 1,2-diamine, right. So this is starting with letter E, not B, okay. Bis is a prefix that is used to denote the number, but the ligand name is starting with E, and here it is starting with C. So this one will come first, and we have 2 chlorines, so I can write dichlorido, okay, then bis, then ethane 1 2, one second, we have ethane, comma 1 2 diamine, okay, dichlorido bis ethane 1 2 diamine cobalt, okay. Now if you see what is the charge of this cobalt, this is X, cobalt can be X, this is -2, this is 0, and this becomes +1, so cobalt 3, clear. So that is the IUPAC name. Now draw the geometrical isomers for this complex. So if you see geometrical isomers means they are asking you for drawing, you need to draw cis and transform. So cis, you can easily do the transform. 2 chlorines we can keep it in the opposite sides, and the En groups can be present as here, right. So this is your trans geometry, right. Next, if you want to do, and we have a plus charge here, so we will show that also. This is plus charge. Now for drawing cis one, what we can do? We will have Cl, we will have Cl, then we have En here, and then you have En here, okay. And this one will give you plus charge, and this will be cis geometry, okay. Done? Okay. So next question. Write any 3 limitations of valence bond theory of coordination compounds. So valence bond theory, there are many limitations. You can see, you can remember any 3 points. First, it has a large number of assumptions, right. So many assumptions have been taken while making this VBT. First limitation, it does not give qualitative interpretation of magnetic data. So why the pairing occurs, okay, why the pairing does not occur in some cases, that was not explained by this, and that is why the magnetic data could not be explained properly using VBT. Next, it does not explain the color exhibited by the coordination compounds, right. So why there is color in the presence of in coordination compounds, or why the transition elements are so colorful compounds, that could not be explained due to the valence bond theory. Next, it does not give a quantitative interpretation of the thermodynamic or kinetic stabilities of the coordination compound. Okay, so based on these structures, based on the VVT, we cannot interpret about the stability of the compounds. And next, it does not make exact prediction regarding the tetrahedral and square planar structures of coordination complexes. Okay, four coordination complex, whether it will be tetrahedral geometry or it will be square planar, we cannot predict here. Next, it does not distinguish between weak and strong field ligands. Okay, it says that, okay, by seeing the magnetic field, we say inner orbital complex and outer orbital complex, but strong field and weak field ligand is not described under VBT. So these are the different points. I can select 3 easy points for you. First one, you can see it involves a lot of assumptions. That is the easy point. Second point, you can just write it cannot explain the magnetic data. You need not write these big words. Just write cannot explain magnetic data. Okay, second point done. Next, cannot explain color. Third point done. Okay, I'll select these 3 points, so that like these points are little more bigger length. Just 3 points. First one, cannot explain magnetic data. Second one, cannot explain color. And third one, it has a lot of assumptions. Okay, fine. Next question. Using the abbreviation of the following ligands, identify the number of donor sites and write the formula of each ligand. Okay. Okay. So EN is ethylene diamine, right? So that is CH2, NH2 and NH2. Okay. EN. So how many donor sites are present here? 2. Okay. Next one is EDTA, ethylene diamine tetraacetate. Okay, so if you see, this structure is like this: CH2N, you have COO minus, then CH2N, COO minus, again COO minus. Okay, so here you have, okay, this is one donor site, this is one donor site, this nitrogen here, and this side also same. So we have 6 donor sites here. Now if you see PPH3, third one, PPH3, pH and pH. Here there is only one donor site and the number of donor sites will be 1 here. Okay. So, okay, now next question. Using VBT, explain the geometry, hybridization and the magnetic moment of COF6 3-. So, this is the most repeated question, very important question. Okay, I'll be just telling you the step how to write down. Okay, step number 1. First step is to write the electronic configuration of CO. Okay, what is the electronic configuration of CO? 3D7 4s2. Now in this particular compound, if you see, the oxidation state of cobalt will be +3. Second line you need to write that in COF6 3-, okay, the oxidation state of cobalt is +3. Okay, this one written. In the same point, you write down the electronic configuration of cobalt with +3 oxidation state. So we will have what? 3d6. Okay, you can write here argon also. I left argon, so just include argon also. Okay. Now third, you need to write about the ligand, whether it is a weak field ligand or strong field ligand. Okay, so and one more thing here, you have to also show the electronic configuration. Okay, 3d6, you show it like this: 3d6, right? 1, 2, 3, 4, 5 and 6. So step number 1 will write, step number 1 you can, will no need to write this one. We'll start with this one. Okay, 1 second. So I'll make it more easy for you. Step number 1, you have to write, first sentence you need to write in COF6 3-, the oxidation state of cobalt is +3. Then you can write down the electronic configuration and then you have to draw the electronic configuration. Below it you have to draw it, okay, not like this. So you have to, okay, just a minute. So you have to write like this: CO plus 3 oxidation state, electronic configuration, write down argon, and then 3d6, and then you draw it here. 1, 2, 3, 4, 5, and then 6. Now second point, write down fluorine is a weak field ligand. Okay, write the full words, not like this. So no pairing of electron takes place. So no pairing of electron takes place. Okay, so now what happens? We need how many? 6 electrons, 6 empty orbitals are needed, but that is not available because this 3D is already there filled, and we cannot even do pairing because it is a weak field ligand. So now what you have to show? You have to show 3D. 6 electrons will be there. Okay, 1, 2, 3, 4, 5, and 6. Next you have to show here 4s. Next 4p. Okay, and next 4d. Okay, after that you have to make a circle, make a combine like this, and show that these orbitals are undergoing hybridization to give sp3d2. So here you have to write 4s, 4p, and 4d undergoes or next point in the next line we can write down. We'll make it in the next line. Okay, so your third sentence will be 4s, 4p, and 4d undergoes hybridization to give 6 sp3d2 hybrid orbitals. Okay, so now you have to draw 6 orbitals. Okay, and write here 6 sp3d2 hybrid orbitals. Okay, third point done. Now fourth one, you just need to draw this again and show the bonds with fluorine. Okay, so after writing these all things, you need to see the question here. Explain geometry, hybridization, and magnetic property. Okay, so geometry is very clear. What will be the geometry? sp3d2 means it is octahedral, right? Next you have hybridization. So next hybridization is sp3d2. Then after this, magnetic property, you find there are unpaired electrons here. So it will be what? Magnetic property is paramagnetic. Okay, after writing these 4 points, you need to write these 3 statements, then you will get full 3 marks in this question. Okay, next, application of coordination compounds. Many applications are there. Some of this you can remember here. Used as a catalyst, used in black and white photography. EDTA, which is used, is used in the treatment of lead poisoning. Cisplatin is used in the treatment of cancer. Okay, so these are the some of the applications that you can note down. Next, out of the following 2 coordination entities, trans is given, which is optically active. So if you remember, the cis one will be optically active. Okay, so I'll just draw in and show you. If you see PtCl2 En2 cis one, so it will be PtCl En. Okay, its mirror image will be non-superimposable, and that is why cis will be optically active. So which is optically active? Cis. Now draw the structures of its enantiomers. So you need to draw the structure of this one. So it is PtCl En. Okay, this is one is there, and another we have PtCl En, and then En. Okay, so now if you see, this is the mirror image. So this compound is not exactly superimposable on this one, so that is why this one will also be optically active. Okay, so these are the 2 enantiomers. Okay, next question. Draw the crystal field splitting in the octahedral system. IUPAC name of the given compound. Okay, first let us write down the IUPAC name. So if you see, you have ammonia, that is amine, and then you have aqua, right? So amine will come first, so we can write triamine. Okay, then you have triaqua. Okay, triamine, triaqua, chromium. because it is a cationic complex, chromium 3, okay, and after that chloride, okay. Then you have draw the CFS splitting of d orbitals in the octahedral system. So T2G will be now down, EG will be now up. You can see the diagram here. Please remember, draw it all the. So here I have written 3d orbitals in free iron. 3d orbitals in free iron. Next, this is what? 3d orbitals, okay, in spherical crystal field, okay. Now here is the splitting. This is T2G. In T2G we have dxy, dyz and dx. This is 3d orbital splitting in octahedral. So you can write down 3d splitting in octahedral field. And here you have Eg, dz square and dx square minus y square, okay. Next you can also level the difference here. This is minus 2 by 5 delta O, and this one is plus 3 by 5 delta O. Clear? Okay. Next, mention the postulates of Werner's theory. So the answer I have already written. So first of all, it has, the coordination complex has two types of valencies, that is primary valencies and secondary valencies, okay. Primary valencies are ionizable and are satisfied by negative ions. The secondary valencies are non-ionizable and are satisfied by neutral molecules or negative ions, okay. We have written the opposite points so that you can remember easily. The secondary valence is equal to the coordination number of the metal and is fixed. Next point, so these 3 points are enough. Next you can write the secondary valencies also give you the spatial arrangement and corresponding to the different coordination number, okay. So main are these 3 points, okay. This is main 3 important points. Primary valencies are ionizable and are satisfied by negative ions. Secondary valencies are non-ionizable and can be satisfied by both negative and neutral ions, okay, molecules. Next question, write the IUPAC name of the compound. Same compound, this is the same compound just now we have discussed. So it was what? Triamine, right? Triaqua chromium 3 chloride, okay. Now geometrical isomers CONH3 whole 4 Cl2. I think this question got repeated. Is it the same question? Okay, geometrical isomers of CH3NH. Okay, this is different, right? So we will have cis and trans here. So we can draw cis and trans. Cl2 I'll draw like this, right? And these are your NH3 molecules. CO NH3 whole 4 Cl2. Okay, so this is trans. And cis one will be CO Cl, Cl, you have NH3, then you have NH3, and then here NH3 and here NH3, okay, and this is your cis geometry, okay. Fine. Next, write the IUPAC name of the given compound. Give the facial and meridional structures of this compound. Okay, so there's only one example for facial and meridional given in the NCERT, and that particular example is asked many times in the exam. Okay, so please prepare this example properly. Okay, first let us write the IUPAC name here. So potassium, first there will be potassium, right? Potassium. Okay. Next, we'll write about the complex oxalate, trioxalato. Trioxalato. Chromium is a part of negative ion, so it will be chromate. Okay. Then what is the oxidation state here? This one is +3. Sorry, this if you calculate here, this is +1 and this 3 has come in, this must be -3. So I'll get x minus 6 is equal to -3. So we'll get x is equal to +3. So chromate 3. Clear? Next, facial and meridional structures if you want to see, this is their example taken from NCERT book. the facial one, this 3 NO2 groups should be in the one face of a triangle. Okay, so you can just remember like this, 3 you should put on one side, another 3 you will put on another side, that is facial. And for meridional, you can put 3 NO2 in one plane, this should be in one plane, and then 3 NH3 you can keep it in this way. This is facial, this is meridional. Okay, so these are the examples. Fine. Okay, so students, we have covered a lot of questions from coordination chemistry as well as from DNF block, and still if you find any question difficulty, or you want any you did not understand any question, then please comment down, I'll definitely address it. And please start preparing for your midterms. Many students do not take your midterm seriously, right? You think no marks will be included, but just think, if you put some effort and you prepare your midterm now, you prepare these chapters thoroughly now, so you will get enough time during the board exams for revision, and you can use time for KCET preparation as well, right? So please prepare accordingly, do not take this lightly. Prepare the questions and please focus on the presentation of answers. You may be knowing the answers, but if you cannot show it on the paper, then you will not be getting the marks. Okay, so please present your answers correctly. Remember all the formulas, DNF block, remember all the reasoning questions. Very easy to score if you just study strategically and you follow this video if you are having any doubt. Okay, so we have already done physical chemistry in the last class. We have completed inorganic chemistry, and the next video will be coming up with organic chemistry. Okay, so thank you for watching, and if you find this video helpful in any way, if it has helped you even a 1% in your preparation, then please subscribe the channel and follow the channel for more such videos. Okay, thank you once again, and all the best for your midterm preparation.